Learning objectives. In this chapter, the user would learn the following in detail: motivation, probability models, probability axioms, sample space, having equally likely outcomes, conditional probability, Bayes formula, independent events. Probability. In mathematics or statistics, a numerical measure of uncertainty is practiced by the important branch of statistics called the theory of probability. Probability equal to events divided by number of outcomes. Consider the following day-to-day life statements. Every day, the sun rises in the east. It is possible to live without water. Probably, he or she gets the job. Random experiment or trial and event or cases. If an experiment is repeated under the same conditions any number of times, it does not give unique results, but may result in any one of the several possible outcomes. Thus, an action or an operation which can produce any result or outcome is called a random experiment or a trial, and the outcomes are known as events or cases. Example number 1. Rolling of a die is a trial and getting 6 is an event. Number 2. Tossing a coin is a trial and getting head or tail is an event. Probability is expressed in numbers between 0 and 1. Probability equal to 0 means the event never happens. Probability equal to 1 means it always happens. The event always happens. The event never happens. Here, event means which is a set of outcomes of an experiment, a subset of the sample space to which a probability is assigned. The total probability of all possible events always sums to 1. Example, tossing a coin. Sample space equal to S equal to H, T. H stands for head, T stands for tail. P of H equal to P, P of T equal to Q. P is success and Q is failure. P plus Q equal to 1. Success plus failure equal to 1. 1 by 2 plus 1 by 2 equal to 1. 2 by 2 equal to 1. Finally, 1 is equal to 1. The sample space of an experiment or random trial is the set of all possible outcomes or results of a particular experiment. It occurs in probability theory. A sample space is generally indicated with set notation. The possible outcomes are listed as elements in the set. It is common to refer a sample space by the labels S, ohm or U. Definition of probability. The probability of an event equals the number of times it happens divided by the number of opportunities. These numbers can be determined by experiment or by knowledge of the system. P is equal to M divided by N equal to number of favorable outcomes divided by total number of possible outcomes. For instance, rolling a die, singular of dice, the chance of rolling a 4 is 1 by 6 because there is a 4 on one face and a total of 6 faces. So, assuming the die is balanced, a 4 will come up one time in 6. The AND rule of probability. 2 or more events are considered to be independent if the occurrence of an event does not affect the occurrence of the other. Event 1, event 2, event 3. For example, if a coin is thrown twice, the result of the second throw is no way affected by the result of the first throw. Thus, the events are independent events called the AND multiple rule because this event happens and that event happens. First throw, event 1 equal to head. Second throw, event 2 equal to tail. For example, what is the probability of rolling a 2 on one die and a 2 on second die? For each event, the probability of 1 by 6. So the probability of both happening is 1 by 6 into 1 by 6 equal to 1 by 36. Addition theorem. P of A intersection B is equal to P of A into P of B. Using addition theorem, P of A intersection B is equal to P of A into P of B only for independent events. Two events are said to be mutually exclusive when both cannot happen simultaneously in single trial, or we can say the occurrence of any one of them excludes the occurrence of the other. For example, the chance of rolling either a 2 or a 3 on a die is 1 by 6 plus 1 by 6 equal to 1 by 3. Addition theorem. P of A union B is equal to P of A plus P of B minus P of A intersection B. Not rule of probability. The chance of an event not happening is 1 minus the chance of it happening. Asking 3. 1 by 6 success. Asking 5. 1 by 6 failure. For example, the chance of not getting a 2 on a die is P plus Q equal to 1, Q is equal to 1 minus 1 by 6. Finally, Q is equal to 5 by 6. This rule can be very useful, sometimes complicated. Problems are greatly simplified by examining them backwards. Getting a 7 on 2 dice. There are 6 different ways of getting 2 dice to sum to 7. Example 1, 2, 3, 4, 5, 6 equal to 1 by 6. Probability of getting 1 or 2 or 3 or 4 or 5 or 6. In each case, the probability of getting the required number on a single die is 1 by 6. To get both numbers, so they add to 7. The probability uses the AND rule is 1 by 6 into 1 by 6 equal to 1 by 36. To sum up the 6 possibilities, use the OR rule. Only one of the 6 events can occur, but you do not care which one. Classical probability axioms. If E is an event and is a subset of S, the sample space, then the following are true. 0 less than or equal to probability of E less than or equal to 1. The probability of an event E is between 0 and 1 is inclusive. The probability of an empty set is 0. Consequence, if probability of A intersection B equal to 0, then A intersection B equal to, which implies A and B are mutually exclusive. Example, tossing a coin, probability of A intersection B equal to probability of A into probability of B is equal to 1 by 2 into 1 by 2 equal to 1 by 4. Then P of S equal to 1, that is called total probability. The probability of the sample space is 1. P of A union B is equal to P of A plus P of B equal to 1 by 2 plus 1 by 2 equal to 1. Types of axiom. There are 3 types of probability axioms. They are first axiom, second axiom and a third axiom. First axiom. The probability of an event is a non-negative real number. P of ohm equal to 1, where F is the event space. In particular, probability of E is always finite, in contrast with a more general measure theory. Theories which assign negative probability relax the first axiom. Second axiom. This is the assumption of unit measure that the probability that some elementary event in the entire sample space will occur is 1. More specifically, there are no elementary events outside the sample space. P of ohm equal to 1. This is often overlooked in some mistaken probability calculations. If you cannot precisely define the whole sample space, then the probability of any subset cannot be defined either. Third axiom. This is the assumption of sigma additivity. Any countable sequence of disjoint synonymous with mutually exclusive events E1, E2, etc. satisfies probability of E1 union, E2 union, etc. equal to summation I is equal to 1 to infinity P of EI. Bayes law. Conditional probability is used to find the probability of an event given that one of its possible cases has occurred. We use Bayes law to find the probability of the possible cause given an event. Definition. Let A and B be two events with probability of B not equal to 0. The conditional probability of A given B is probability of A given B equal to probability of A intersection B divided by probability of B. If you are given that the event B occurred, the relevant sample space is reduced to B, P of B equal to 1 because we know B is true, and the conditional probability becomes a probability measure on B. Probability of A given B is equal to probability of A intersection B divided by probability of B can be rearranged to probability of A intersection B equal to probability of A given B into probability of B, and since also probability of B given A is equal to probability of A intersection B divided by probability of A. Therefore, probability of A intersection B equal to probability of B given A into probability of A. Probability of A given B into probability of B equal to probability of A intersection B equal to probability of B given A into probability of A. Probability of A given B is equal to probability of B given A into probability of A divided by probability of B. Bayes rule. P of AI given B equal to P of AI into P of B given AI divided by summation P of AI into P of B given AI. Why is Bayes rule useful? It turns out that sometimes it is very useful to be able to flip conditional probabilities. That is, we may know the probability of A given B, but the probability of B given A may not be obvious. Conditional probability is the probability of an event occurring given that another event has already occurred. Worlds in which A is false, worlds in which A is true. P of A is equal to area is yellow circle, its area is 1. Event space of all possible worlds. The conditional probability of event B occurring given that A has occurred is denoted by probability of B given A and is read as probability of B given A. We may be interested in the chance of an individual getting selected in the medical test given that he has been selected in the interview. This type of probability is called conditional probability. A, B. Probability of A given B is equal to probability of A intersection B divided by probability of A, provided probability of A not equal to 0. The conditional probability of A given that B has occurred is defined by probability of A given B is equal to probability of A intersection B divided by probability of B. Probability of A given B equal to probability of A given B has happened. Conditional probability. Example. Consider a temporarily ambiguous but generally late pottery type. The probability that an actual example is late increases if found with other types of pottery that are unambiguously late. P is equal to probability that the specimen is late. Isolated. Probability of T of A equal to 0.7. W given late pottery TB equal to P of TA given TB equal to 0.9. W given early pottery TC equal to P of TA given TC equal to 0.3. If A and B are independent, then probability of B given A is equal to probability of A into probability of B divided by probability of A equal to probability of B. Independent events. When two events are said to be independent of each other, what this means is that the probability that one event occurs in no way affects the probability of the other event occurring. An example of two independent events is as follows. Say you rolled a die and flipped a coin. The probability of getting any number face on the die is no way influences the probability of getting a head or a tail in the coin. Dependent events. When two events are said to be dependent, the probability of one event occurring influences the likelihood of the other event. For example, if you were to draw a 2 cards from a deck of 52 cards. If on your first draw you had an ace and you put that aside, the probability of drawing an ace on the second draw is greatly changed because you draw an ace the first time. The rule of total probability. The law or formula of total probability is a fundamental rule relating marginal probability to conditional probabilities. Law of total probability. P of B equal to summation P of B intersection AI equal to summation P of B given AI into P of AI, where AI intersection AJ equal to empty, mutually exclusive, and union AI equal to ohm, collectively exhaustive. Joint probability is the probability that two events will occur simultaneously. Marginal probability. Marginal probability is the probability of the occurrence of the single event. The law of total probability. If A1, A2, etc. An are mutually exclusive events, then the law or formula of total probability is a fundamental rule relating marginal probabilities to conditional probabilities. A1 union A2 union etc. union An is equal to S, that is called sample space, and if B is another event, then probability of B equal to P of A1 into probability of B given A1 plus P of A2 into P of B given A2 etc. P of An into probability of B given An. Now we are going to see an example for law of total probability. There are three boxes, each containing a different number of light bulbs. Box 1, box 2, box 3. The first box has 10 bulbs, of which 4 are dead. The second has 6 bulbs, of which 1 is dead. And the third box has 8 bulbs, of which 3 are dead. What is the probability of a dead bulb being selected when a bulb is chosen at random from one of the three boxes? Probability of dead equal to 1 by 3 into 4 by 10 plus 1 by 3 into 1 by 6 plus 1 by 3 into 3 by 8. Finally, the answer is 113 divided by 360. Conclusion. In this chapter, we have covered the following in detail: motivation, probability models, probability axioms, sample space having equally likely outcomes, conditional probability, Bayes formula, independent events.